Okay, good morning everybody. Welcome to the AnyLogic workshop and the AnyLogic conference. There will be two of us. Nikolay is head of AnyLogic software development, and myself, I'm CEO of the AnyLogic company. This workshop is 1 hour. It's pretty technical, kind of low-level technical workshop. We will be mainly working with the currently released product, which is 7.3.6, yes. And we'll demo some new features like the road traffic library and also do some tips and tricks. As you can see on the slide, there's kind of this infinity sign, which actually is number 8. For the AnyLogic 8. So we will uncover a little bit of the AnyLogic 8 Cloud, but that'll not be the main topic of this workshop, because we have the main presentation on the AnyLogic 8 today, this afternoon at 4 o'clock. Okay? But we'll show some of that. The agenda will be maybe 20 minutes to have an hour demo of the road traffic library, which is our latest addition to, let's say, our logistics package, where we have the rail library, the pedestrian library, and now the road traffic. And we'll build a model of an intersection. And then, as a bonus for those who came here this morning, we will export the model to the AnyLogic Cloud and show you how the cloud works. And then some tips and tricks, some really technical things, showing you what you can do with the tool and how it's done. As always, please make this workshop interactive, so raise your hand, ask questions as we will be going. With regards to you working on your laptops, it's up to you whether you can watch us or you can try to do something in parallel. Some of the examples where it said show and discuss, we will not be building in front of you because it'll take too long, so we will show you the model structure and discuss it with you. And some others we will build from scratch in front of the audience. So that's it for the introduction. And I'll pass the mic to Nikolay. Okay. So, somewhere here in this, you can put it in your pocket.
Mm-hmm. Okay, the first model in which we will demonstrate new road traffic library is an intersection model. Here I'll pick up some of the road intersections nearby. It will be intersection of Broadway and 2nd Avenue here in Nashville. Yeah. And I'll build a road model over this intersection and show you some features of road traffic library, and after that we'll export this model to AnyLogic Cloud. So let's switch to AnyLogic. Here is AnyLogic. I create new model, intersection. So this is our new model. Now let's grab some map for it. I will draw road markups over the satellite image. Here is Broadway, Nashville, and 2nd Avenue. I zoom in so we can see these roads. Now I take a screenshot. So it's in clipboard, and now let's paste it into AnyLogic. reset to original size. I'm going to draw roads over this image, but they are gray as well, so I need to put some screen or some semi-transparent rectangle over this image. So I draw a rectangle here and change the transparency. So it will be like some background image. Now I select both of these shapes and lock these shapes. So they will be just a background, they are not selectable, and well, they allow me to draw over them. Now let's switch to road traffic library palette.
By the way, guys, anyone has used the road traffic library yet? 1, 2, 3. Right. Okay. So, so maybe some introductory words would make sense. So the road traffic library, which you can see here in this palette, is a micro simulation of road traffic. So micro simulation means that cars are. I'll stay close to the mic. All right. Okay. That cars are like physical objects. They see each other. We do model explicitly how they accelerate, decelerate, change lanes. We do model in this library the driver's behavior, etc., etc. So it's really accurate simulation of road traffic, similar to what we have in the pedestrian library for pedestrians. And it can be used to do like intersections, I mean the urban traffic like here, or it can be used, and it's used already a lot, to model and simulate traffic at, let's say, production sites, inside buildings, outside buildings. So it's a multi-purpose library that you have here in AnyLogic, as a standard library set for our AnyLogic Professional. And you will see in a second how it works.
Okay, now I'm going to draw roads over this image. So first, let's add the second avenue. By the way, this road is a one-way road, so I check here one way. And the next one is a Broadway. So you can see an intersection appeared here. Automatically. Now I will change the number of lanes here. Sorry. With like this. And add this part of Broadway. This road has a median strip. Will be, for instance, 7 feet. And I will increase the ends of these roads for the cars to have space to ride from.
To decelerate before the intersection.
Now we can modify the lanes here on the intersection. We can click like here and add more lane connectors over the intersection, and it looks like it's okay. The leftmost lane from this part of Broadway is on the left, like on this image. So the third lane is left only. Okay. Now I'm going to add a traffic light here. I drag and drop traffic light block from our traffic library palette and choose here intersection, this one. You can see in the properties of traffic light there is a phases table with initially filled 2 phases of 10 and 15 seconds. I will correct them to be 45 and 30. Sorry. So this phase will turn on green lights for these 2 stop lanes. Stop lines. So it will be Broadway, and this phase will be 2nd Avenue. So you can observe these phases either on the table or on the graphical editor by their colors. Now I'm adding car movement logic. So it will be flowchart, simplistic flowchart: car source, car move to, and car dispose. Our cars will appear on this road, and they will take to the left here. Now let's run the model. You can see cars are moving here. They're changing the lane because all of them want to turn left. Red, currently red. Because traffic light, okay, it's green now, it's free to turn left. Okay, now let's populate all the remaining roads with cars. I'm going to add the collections of start and end points and use these collections here in the car source and car move to pick up a random road to create a car and choose a random destination to move this car to. What I'm doing, I'm selecting these three roads and create collections here, a collection here by the right-click menu. This collection will be named Start Roads, and destinations will be stop lines. I will add 3 stop lines here, 1 here, and at the end of road segment, 1 here, and 1 stop line here on Broadway. Okay, now I select these 3 lines, stop lines, and choose to create new collection. This will be named End Stop Lines.
Yeah. So I don't know how long ago we added this way of creating collections by selecting a number of objects and then clicking, right-clicking. But it's pretty useful because it saves you, may save you a lot of time. You don't have to type anything. You just multiple selection and then right-click and then create collection.
And you can modify this collection later by adding more stop lines here, or by removing stop lines from this list, or switching to the code behind these initial contents.
If you want. Yeah.
If you want. Okay, now in our car source, I go into the road parameter and change it to dynamic value. Here I type in some simple function, random from, and choose here our start roads collection. So this function will randomly select one of roads in that collection and return it. In car move to block, I change the mode of movement, so our cars will move to stop line, and the stop line the same way will be randomly chosen from the second collection. Okay, now you can see our cars are moving by all these roads. They are stopping in front of traffic light and waiting for green light. So they are moving now. I will increase the rate of cars from the default 1,000 cars per hour to 3,000 because we have 3 starting roads here. You can see this car wants to turn left and it holds the right lane. It's like in real life.
You'll be able to model like car like stopping or a car that wants to park, and then while it's parking, the other cars have to wait. So all this sort of stuff is in there. Yeah. So we have also here objects like parking lot or bus stop that you can attach to roads, and you can then tell the cars, okay, this car wants to park there, or appears at parking. So yes, this sort of stuff.
Okay, so I could possibly have a car just stop in the middle of the road and call that an accident, but I would then need to wait for the tow truck and the police to arrive. Is there a way I can model that?
You will have a kind of like stop line or other place where the car would stop, and you will consider that as an accident. So the other cars will be trying to kind of find a way around that car, and then you can send a special car from somewhere else. So yes, you can.
Now it's possible here in the US to turn right on red. Now let's add this function here. This traffic light block currently it's working with stop lines. Our intersection has three stop lines, and we can switch this traffic light to work with individual lane connectors, so these thin white lines. So I click here, and our phase table is automatically converted. So this is, I'll zoom in. This is the first phase. This is the second phase. What I do here, I simply turn this simply switch this right turn from red to green on this phase. And this phase has this one. So I enable turn on right
So
here.
they're basically always enabled, right? Because they're always green.
Yeah.
Mm-hmm.
Now I'm going to add density map for cars here. I use this road network descriptor block and turn on density map here. By the way, this is a more detailed level block. It is useful to set up some internal options of road traffic library to listen more different actions, events, etc. So I've enabled density map here, and now our intersection is showing in color how many cars are there, how many time they spend, or generally their average speed. If they are moving too slow, roads are red, like in a traffic light, or like in traffic jams showing systems, like on Google, etc. Okay, all the models are usually built to get some outputs, to get some observable data. Why do we model? So here I'm going to add some model output. I will measure the time spent by the car in our system. As Andrei said, I can use here blocks from other libraries. So I switch to process modeling library and use time measure start block. Okay, and time measure end. In this time measure end block, I choose that it's connected with this one, so they are like the pair. And to visualize this time in system, I use a histogram chart and get here time is histogram. Title is time in system. It looks like the majority of cars spends about 100 or seconds, so like 2 minutes in our model, and there are cars spending about 5 or more minutes here. Okay, now let's add the 3D visualization. So I create 3D window here from our presentation palette. It will be our view, and for the cars to look better, I choose here in car source to create a custom type for our cars. It will be named car, and we'll have an animation of this one car. No parameters. Okay, finish. So this is our new agent. looks like our white rectangle is
Yeah, has some
has some Z height.
Let's. So when we were putting this shading rectangle, it by default has some Z height, which we don't want. So.
Okay, to perform some experiments with this model, we need to add parameters, and I will parameterize our traffic light by adding parameters phase Broadway. It will be the length of Broadway phase. It's of time type and has a 45 seconds value by default, and one more parameter phase Second Avenue. Is 30 seconds default value, and in the traffic light block I choose here phase Broadway parameter, and this parameter here. Okay, now let's show you AnyLogic Cloud. It's time to use it. I will use Cloud to experiment with these parameters to find better ones based on the histogram. Here, this is a new run configuration element. It's like an interface of AnyLogic model in the AnyLogic Cloud. And it describes the model in terms of black box, like inputs and outputs. On the left part, here are all the possible inputs.
Suggested inputs that
yeah.
you may want to expose in the cloud.
We add here our two parameters, and for outputs I add here our histogram.
That's all we have at the moment.
Yeah, and let's set stop time to 1000 seconds. And simply choose here or from here, export to AnyLogic Cloud. Save changes, create new model. So it's being uploaded. Probably this is because of our image waiting for upload. Login here. So this is our new website, AnyLogic Cloud. This is our experiment with its inputs. So I just press run button here, and it's being executed. And this is our histogram. Now let's change.
So the actual model was run on an Amazon server somewhere, and the results were delivered to here, right? So what we did, we actually uploaded the model to the Amazon cloud, which is currently the default, let's see, provider for the AnyLogic cloud. And the model sits there, and it's just been executed on one of the nodes, and the results were delivered to the browsers.
We can change inputs here, for example, phase of Broadway, traffic light, and probably 1 minute. You can see this time in system histogram became better. All these charts are observable. You can look into them, and if you change values back, all the results are automatically taken from AnyLogic Cloud, because AnyLogic Cloud stores all the model runs you have performed, all the outputs, and they are automatically taken when you type some inputs which were already used.
So input-output pairs of all ever performed experiments are stored in the cloud, and they are available for immediate reuse. So you don't have to, especially when your model is computationally intensive, you don't need to run it again with the same, if you have the same parameter sets. Animation in the cloud?
Oh, sorry, forgot. Yes. It's possible here not only to observe data, but look at the really executed animated model. So I can click here, play. What's happening now is our model is executed somewhere on the computational node in cloud and on Amazon, and it delivers like frames of animation to our browser, and browser simply renders these frames. Yeah, and the animation is
it's a vector
animation. You can pan, you can zoom out, zoom in, and charts are also
it's like responsive and interactive, and the kind of lag between the model which is being executed somewhere else and the browser is minimum.
Can I do this without an AnyLogic license?
Okay, so to a certain extent you can, because if you just log in to the AnyLogic Cloud, or if you maybe log in as a guest, you will have access to a gallery of public models. Can you show that? Yeah. So you will see that, and you will maybe you can run some of the models with the animation. So. Even if you don't have any AnyLogic license, you will be able to do and to what Nikolay is currently doing.
So it's fully interactive. You can change the model speed. You can set on a pause and navigate, resume model execution.
So that yeah, just a second. That's why I'm saying that the it's not right to treat cloud as just a computational resource that you have out there, right? So it's more like, you know, having all your simulations ready to run at any time. It's very portable. The same thing can be run from your phone, iPhone or iPad, right? So to collaborate, and you don't really need AnyLogic to run the models, to discuss models, to experiment with them, to compose new experiments, because AnyLogic, the AnyLogic model development environment is only needed to develop the model, right? To debug it. Once the model is ready, it's there, and you don't need AnyLogic anymore. That's the thing. Okay, so basically that's the simple like tip on what do you do when you want to dynamically display a route on a GIS map when this route is in use, and then delete it after the vehicle is done with the route. So what we will do, we will create a simple like a couple of delivery trucks that will travel between certain points and show you how to create the route dynamically. Okay.
Okay. So create a new model here. First of all, we need a GIS map. Okay, our tracks will be moving in Nashville. Let's add some nodes. Can also create manually by dragging them from palettes. So currently I've created two GIS nodes based on geographic search and adding some more points here. Now let's create a collection here. We'll direct our tracks from one node to randomly chosen destination. This will be our source. Agents will appear in some node. Little bit Sheraton here, and they will move to some. Let's use that function, random from. And then sync. And let's create agent type with animation. It will be like this track. And okay, good enough for now. Our source now creates these my agents. Can their name maybe? Okay. Too many of cars. That'll be one per 10. Maybe 10 per hour, maybe. So they are moving, and now I'm going to add routes to be displayed on the map. What I do, I create a function here which will find the root from the GIS map and add it to the map to be displayed. It will be named I will use this function in instead of this random from code. I will type here get destination of agent, and our function will have an argument drag of type. It's my agent. Okay, I can rename it to my drag, etc. And function return type is GIS point. I've pasted that random from call from Clipboard, from that place, and this node will be chosen here in this random from call and returned back to move to block. So it's like this function is like a place for us to execute some additional actions in between of calculating the destination node and sending the car actually to that node. And here I am going to create a root shape and add it to the map. And after the car arrives to its destination, I'm going to remove the route from the map. So I need to store the link to that route. I go to our car type and add here variable for
So while the car is alive, it will hold a reference to its root inside.
in our function I use here. So we just created root variable here. And I call our map. Get root.
So that is actually a query which goes to our server, right? Get
Right.
root. Mhm.
And I change the line color to dark red to be visible. And what I've written here, I call get root from the map, so it calculates the route from the track point to node latitude longitude and adds it to the map. And if in the move to block on exit, when our track arrives to its destination, I need to remove that shape from the map.
That's it.
Oh, sorry, not the dark agent here, because we have keyword agent. Agent here, it's gonna be observed here when you point mouse on this sign. I need to increase the rate, maybe. They're moving so rarely.
Yeah, so either decrease speed or increase rate, something like that.
So now routes are displayed here, and they disappear when the car reaches its destination.
Mm-hmm. Yeah, so this is really an advanced usage of AnyLogic API. So for simple stuff like just send the car somewhere along the roads, there's no coding. If you want something really sophisticated, like here, dynamically display a route, there's still, as always in AnyLogic, you still can do that, but you need to know the API of all those things. So just that was kind of some really sophisticated examples. So can we go back to the presentation? But we so we'll finish here. And guys, thank you for being with us this morning, and we're looking forward to seeing you all during these 2 days at our presentations and workshops. So thank you very much.